This podcast is to review some of the sampling techniques that are talked about in Chapter 6, but also to talk about a few other types of sampling that weren't covered in the chapter as well. When you are talking about external validity of a study, the sampling procedures that you use are very, very important because your sample might have bias. Any time that you take a sample from a population, you run the risk of having what's called sampling error. This means that there is a difference between your sample and your population, and depending on the type of sampling that you're doing, you could have differing amounts of sampling error. There are two main groupings of sampling: probability sampling and non-probability sampling. Probability sampling is one type of sampling that you can use that is better for ensuring a more representative sample. This is because you know the parameters of the population, you know what the population looks like, so you can calculate the odds of being sampled, and you can also build your sample so that it represents the population. But probability sampling means you know the parameters of the population. That is the biggest part there. When you talk about probability sampling, one of the most common ways that we talk about with sampling is simple random sampling. This is kind of the gold standard in the field. But it's very hard to do because you have to have a population, and each person in the population should have an equal and independent chance of being selected for your study. Now, I don't know how much you know about probability. We're going to talk more about it in later chapters, but you need to know that basically with probability, the probability of any outcome is based upon the number of outcomes that could possibly be the one you're looking for over the total number of possible outcomes. So if I put, let's say, 10 people in a room, there are 10 total outcomes, 10 people, and I chose one person from the sample. But in that 10 people, I had 5 women and 5 men. You could say the probability of choosing a woman would be 5 out of 10. The probability of choosing a man would also be 5 out of 10. When you're talking about simple random sampling, everybody in your sample has to have that same probability of selection. Another thing that you need to know when you're calculating the odds of selection is with and without replacement. If you are doing simple random sampling, you have to have an equal chance for everybody to be selected. So if you have 100 people, and each person in your population might be selected, you're selecting one person, you would have 1 out of 100 would be your probability of selection. But if you take a person out, so you sample, you take one person, you run that person in your study, now everybody else that's left has a 1 out of 99 chance of being selected, because now there's only 99 people because you took one person out. This would not be an equal chance for everybody. You would have to put that other person that you already ran, you'd have to put their name back in the hat so that everybody would still have the same equal chance. So if you're doing a true random sample, this means that you would have your sample taking place with replacement. So everybody goes back in and everybody has an equal chance. If it's without replacement, you would take the person out, and the next time the odds are going to change after you select each person out. Another type of probability sampling is systematic sampling. This would be where you would choose a random starting place in a list and then sample every nth place. So you would choose a number like 9, and you would sample every 9th person in your list. And then finally, you have, not finally, but then you also have stratified random sampling. Stratified random sampling is very similar to simple random sampling, except you put people in groups first. And this is to ensure that you sample from all of the different subsections of your population. So if we're looking at college students, we could do a simple random sample for everybody at Georgia State and just pick names out of a hat. However, that might not get us an equal chance of getting a sophomore, a junior, a senior, or a freshman student. And we want to make sure that we have people from each section in our sample. So with stratified random sampling, you would group all the freshmen together, all of the sophomores together, all of the juniors together, all of the seniors together, and then you would take a random sample from those groups. This is a good technique, particularly when you want to compare groups statistically, because if you're comparing groups statistically, you want to make sure that you have the same number of people from each group, so that each group has equal power in the sample. So you would have 10 freshmen, 10 sophomores, 10 juniors, 10 seniors, but within the seniors, you're randomly selecting those people. You can also have proportionate stratified random sampling. Proportionate stratified random sampling is more like if you want to ensure that your groups are represented in your sample the same way that they're represented in the population. So if you have at Georgia State 30% freshmen, you would want 30% of your sample to be freshmen. So you would tailor the numbers. Instead of selecting 10 from each group of freshman, sophomore, junior, senior, you're going to select the proportion of people from that group that are represented as the proportion at the university. Your book also talked about a technique called oversampling for stratified random sampling, and this is where you are selecting more people than you need in an underrepresented group. Our last type of probability sampling that I want to talk about is cluster and multistage cluster sampling. Cluster sampling is where you randomly sample groups from a population instead of people from a population. So if I was interested in students who are taking a statistics and research methods class, I could take all of the sections of 3510 and put the 6 sections that we have of this class in a hat, and then randomly select one of the courses, one of the sections of the class. That would be a cluster. And then I would take that cluster and sample everybody within that cluster. So your cluster would be like a class. You sometimes see this as a cluster as a school, or a cluster as people on a street, things like that. But you select a group from a set of groups, and then everybody in that group gets sampled. Multi-stage cluster is when you break this up into stages. So for example, maybe I am interested in homeowners, so I might randomly select states as a cluster, then randomly select zip codes within the state. Those are clusters. Then randomly select streets within a zip code. That would be multi-stage cluster. So you select different groups throughout the process at different levels. Now, with that, those were all of the examples of probability sampling. You also have non-probability sampling. Non-probability sampling means that you aren't taking into consideration really the parameters of the population. In most cases, you don't even know how large the population is. So you're not going to be able to calculate the probability of an outcome or a probability of selection here. You don't know the entire population. This is what happens in most studies. The first type that I have up here is haphazard, convenience, accidental. These are all basically the same thing. It's that you select the people who are easiest to get to, who just kind of come across your path. Whenever we are using undergraduates in a study from Psych 1101 classes, those are a convenient sample. It's the easiest people we can get to. Purposive sampling is when you can identify a particular group that you want to sample from. And you can do this in 3 different ways. Quota. Quota is you identify a particular group, and then you have a number of people that you want in that group. Like, say I want 10 females and 10 males. I'm just going to go out and look for 10 females and 10 males. I'm going to meet a quota. Expert purposive sampling is you don't sample from everybody in the general population. You find the people with the information that you need, who are experts in that area. So if I want to get information about, let's say, college curriculum, I could sample from presidents of universities. Those people are going to be experts on college curriculum. Or I could sample instructors at universities, something like that. But those are people who will know the information that I want. I'm going to go directly to them. I'm not going to bother with other people. And then you also have snowball. Snowball is who do you know? So with who do you know, it's like you have someone who comes into your study. This happens a lot in developmental studies. You have people come in, like say with their 3-year-old, and you're trying to gather participants. So what you say is, well, if you know anybody else with a 3-year-old, can you give them our information? Maybe they would like to participate in our study. So you ask the person that is there for your study to give you more names. And it goes on from there. I am going to post a link, actually I have already posted a link in the supplemental materials section of the materials for test 3. And there is a link there on a workshop on sampling that goes over all of these different techniques. And I encourage you to go take a look at that and try it out.